All right, y'all. So 9.6 deals with solving equations. So those properties we learned yesterday are going to be really handy today when we're solving these equations, okay? So 9.6, we'll be solving exponential and logarithmic equations. Alrighty, so we will start out by solving exponential equations. All right, y'all, let me let one in real quick. All right, so exponential equations come in this form where you got a base raised to an exponent equal to y. So the same form we've been doing all section here. So the exponent is the variable. So how do we solve equations when the exponent is the variable? So what's going to help us in this section is what we call the base exponent property. So y'all, this is just a little property, and it says if a to the x equals a to the y. So notice you got two sides of an equation with the same base, and they're both raised to exponents. If the bases match up, then that means that x has to equal y. So if two sides are equal and they got the same base, that means their exponents got to be equal, okay? So this base exponent property comes in handy when you're solving exponential equations. So y'all let me write the steps to solving exponential equations. All righty. So there's two cases that can happen when you first start on these. Either you can rewrite each side using the same base, or you can't. So over here, if we can rewrite each side using the same base. So that means I go in on each side and I can rewrite them so that their bases match. If we can rewrite each side using the same base, then we're going to set the exponents equal to each other based on this base exponent property. So set the exponents equal to each other. Once I've set my exponents equal to each other, we will then solve for the variable. And y'all, once I solve for the variable, if needed, I will check my answers. So check answers if needed. So if I could rewrite each side using the same base, this is my steps I'm going to do, okay? If we cannot rewrite each side, using the same base. So if I can rewrite them, I'm doing these steps. If we cannot rewrite each side using the same base, then our first step, we're going to take the log or ln of each side. So I'm going to take a log of each side. Because remember, if I take the log of a base to an exponent, using the power rule, I can then bring that exponent down to the front. So bring the exponents down. Using the power rule. Once I've brought that exponent down, I can then solve for it. So then I will solve for the variable. Now, if it's where we're not able to rewrite each side using the same base, these are going to have logs or LNs left in the answers. So we're going to round the answer to 4 decimal places. And then y'all finally check answer if needed. So you'll see that these, where we cannot rewrite, we're going to be left with our LNs or our logs. So we're going to be forced into rounding those off 4 decimal places, okay? So you will definitely need a calculator for this part. Over here, if you can rewrite them as the same base, then all you're doing is solving for those exponents, okay? So y'all, let's play with some examples. So the first 9 on this homework are solving exponential equations, and then I think the last 8 will be doing logarithmic, okay? And these will all say the same thing. Solve for x. So y'all, let's start with number 1. I got 2 to the x equals 32. So we've got to determine, can we rewrite it using the same base or we cannot? Can we rewrite 32 as 2 raised to an exponent? Does 2 multiply it times itself to give me a 32? So y'all, you would start with 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So you can use 2 multiplying times itself to get a 32, and that was 5 2's. So what I'm going to do is I'm going to rewrite 32 as 2 to the 5th power. So that's going to give me 2 to the x equals 2 to the 5th power. Okay? So take the base and multiply. If you can get 32, by multiplying that 2 times itself, then we can rewrite it using the same base. Well, right here we said, if the bases match on each side, that means the exponents are equal to each other. So the bases match. So that means x equals 5. So y'all, let's check it. If we put a 5 in for the x, does 2 to the 5th equal 32? Well, y'all, if you want to check that, we got a calculator. Let's punch in 2, put in our exponent of a 5, hit enter, and that equals 32. So our answer checks out for number 1, okay? For number 2, they got 6 to the 4x equals 216. So y'all, let's ask y'all this. Can we rewrite 216 as 6 raised to an exponent? So can we multiply 6 times itself to equal 216? And y'all, that would definitely be able to check out on my calculator. So let's try it and see. So I'm going to do 6 times 6. That equals 36 times 6 equals, oh, y'all, look at that. Multiplying 6 times itself, I got 216, and I used 3 6s on that. So I can rewrite 216 as 6 to the 3rd power. Okay, because 6 times 6 times 6 was 216. So the left side will stay 6 to the 4x. 216, I'm writing as 6 to the 3rd. Well, y'all look at that. These 6's match, so my bases match. So that means 4x equals 3. So y'all on this one, I have one more step. So I need to make that a 1x. So I'm going to divide both sides by 4. Because 4 divided by 4 gives me 1x. And then y'all, we can't do nothing with that. So that'll stay 3/4. But y'all, if you put a 3/4 in for that x, those 4's will cancel. And you'll be left with 6 to the 3rd equals 216. Well, we know 6 to the 3rd equals 216, so that would work out true, okay? So that's going to be the trick if we can actually rewrite them using the same bases. So number 3, they're giving us a 2 to the x equals 23. So the question is on y'all. Can you rewrite 23 multiplying the 2 times itself? And so y'all just start multiplying 2 times itself. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So that's already too big. So I cannot rewrite 23 using a base of 2. So we cannot rewrite. So since we cannot rewrite, we said that we need to take a log of both sides. So I'm going to do the log of 2 to the x equals the log of 23. Remember, I can take a log over here as long as I take a log on that side, okay? So as long as we do the same thing to both sides, we can actually take a log of both sides. But y'all notice what I can do now. My next step, using the power rule, bring the exponent down to the front. Well, this side don't have an exponent. So all we got to do over here, we're going to bring the x down to the front so that I get an x times log of 2 equals my log of 23. So y'all see what's about to happen? Here's my x I'm solving for. It's being multiplied by log 2. So if I want to get this x to be by itself with a 1 in front of it, we need to divide both sides by our log 2. Okay, because those log 2's are going to cancel out, leaving the x. And then over here, we got our log 23 divided by log of 2. So y'all, like I said, this side cancels out. We got our x. Now, since we're going to approximate the answer, they use those little squiggly equal signs. Now, I'm going to do this on the calculator, but here's the trick. You gotta close your parentheses around those logs when we punch them in, okay? Because the calculator is going to give you one, and then you got to shut them. So I'm going to go to the calculator, and we're going to round this off 4 decimal places. All right, y'all, so I had a log of 23, so log 23. See how it gives you the first parentheses, and then you close it. And then that'll be divided by the log of 2, and then shut those parentheses. All right, y'all, so we're going to hit enter and see what we get. So we're rounding 4 decimal places, so that's the 5, 2, 3, 5. The second 5 is in the 4th spot, but you always got a 6 behind it. So I got to round that 5 up to a 6. So this will give me 4.5236. Okay, so that's the only trick you got to worry about on these is rounding them off to 4 decimal places, okay? All right, so let's see. Number 4. So this is the second type. The other type is if I can rewrite them, okay? All right, y'all, so watch this. 2 to the 7x minus 1 equals 16. All right, y'all, so I'm going to see if y'all can respond to this one. Can we rewrite 16 using a base of a 2? All right, so Jackson, definitely. So I'm going to rewrite 16 as 2. Well, let's think about it. 2 times 2 is 4, times 2 is 8, times 2 is 16. So I did that 4 times. So 2 to the 7x minus 1 equals 2 to the 4. So it looks like this is the one where our bases actually match up. So since my bases match, that means that the 7x minus 1 has to equal our 4. All right, so notice this one don't have any logs in it, so I don't have to worry about doing all this rounding off, okay? So we're just going to what? Add a 1 to both sides to get the 7x by itself. All right, so 7x will equal that 5. And then turn 7x into 1x, we will divide by 7. All right, so 7 divided by 7 is 1x. Y'all don't look like that's going to reduce, so that'll equal a 5/7. So if you put the 5/7 in for the x's, the 7's cancel. 5 minus 1 is 4, and 2 to the 4th equals 16. Okay? All right, y'all. So that's the trick. We're going to just see if we can rewrite these or not. 3 to the x equals 8. All right, y'all. So can we rewrite that 8 using a base of a 3? All right, good job. That is definitely a no. Cannot rewrite. Doctor, if you start with a base of 3, 3 times 3 is already 9. So that's already too big for that, okay? All right, so he cannot rewrite. So we're going to do the same thing we did here. We're going to take the log of both sides up here, okay? So that's going to give me a log of 3 to the x. That's going to equal log of my 8. All righty. I can now invoke the power rule and bring that x down to the front. So I get an x times log 3 equals a log of 8. And y'all, that's the only reason we're taking logs of these, because that's the only way we got to bring the exponents down, okay? Is by taking logs and utilizing the power rule logs on that. And you know, look here, same thing. Once I got it down, I divided both sides by the log. So I'll divide both sides by the log 3, since that's what's being multiplied by my x. So I'm going to sort of undo a little multiplying by dividing on that side. And then that'll equal my log 8 divided by my log 3. So y'all, the logs cancel, leaving my x. So once again, this is going to be an approximation. Okay. Now, when you punch this in, remember, you will have to put your parentheses around it. But on that one, I ended up getting a 1.8928. All right, y'all. So, questions on these yet, or any anything sort of confusing y'all? All right, so y'all looking good to go then. All right, y'all look at this. I got 10 to the negative x equals 4 to the 5x. Now, y'all, we will go through this and I'll show you the long way to do this. But let me tell you, when you got a variable as the exponent on both sides of an equation, but they got different bases, there's only one exponent that we could put on top of both of these numbers to get the same answer out of them. So can y'all think of what exponent could I raise both of these two on both sides to give me the same answer here? Well, y'all, we know it ain't 1 because you put a 1 in here, that gives you 10. You put a 1 in here, that's 4 to the 5th. Whoo, that's way too big. It ain't going to be a 2 because squaring this side and that'd be 10 on that side. But there is one exponent that I could raise both sides to and get the same answer. And y'all remember this one. Anything to the 0 exponent equals what? equals 1, y'all. So that's the only answer I can possibly put here on these two numbers, right? 10 to the 0 equals 1, 4 to the 0 equals 1. So that means when I'm done, we're probably going to get a 0 on this one. Okay, y'all. So this is sort of a long one, but here's how this one goes. I can't rewrite these. I can't do nothing to a 4 to make it look like a 10 or vice versa. So we cannot rewrite. So since I cannot rewrite, I'm going to take a log of both sides. Log of 10 to the negative x equals log of 4 to the 5x. All right, let me separate that a little bit, getting a little close there. All righty. So all I did was took a log of both sides, but that lets me bring the exponents down on both sides. So the left side, I'll get a negative x log 10. That'll equal the right side, 5x log 4. All righty, so all my exponents are now brought down. So what I'm thinking here, we're solving this for the x's. So somehow I need all the x's on one side together. So what I'm going to do, I'm going to move this one, since it's negative, over to this side. I'm going to add an x log 10 to both sides. Well, a negative x log 10 plus a x log 10, those cancel, giving me a 0. Now, these are not like terms because the logs don't match up. So that means I'll have a 5x log 4 plus a x log 10. So I just brought this one over and made it positive, basically. So now here's my dilemma. I got an x here and I got an x here. I need to figure out a way to get my x's together so I can actually solve this thing. So y'all, here's what we're going to do. We're going to do a little bit of factoring to this. So let me ask y'all this. You got two things sitting here, a 5x log 4 and an x log 10. What do them two terms have in common? Oh, Nat, good job. They both have an x in them. So we are going to factor that x out like a greatest common factor. All right, y'all, because you factor the x out, that's going to leave me a 5 log 4 plus my log 10. Good job on that, Nat. Good job. So here's my x I'm solving for. This x is being multiplied by everything in parentheses. So what we're going to do now is divide both sides by all this in the parentheses. So that'll be 5 log 4 plus log 10. That'll equal my x times 5 log 4 plus log 10 divided by 5 log 4 plus log 10. So you had to do that so that this stuff sort of canceled on that side, and all that left was my x. But y'all look at that. I got a 0 divided by a lot of stuff under here. Well, it don't matter what all this stuff is. 0 divided by anything is 0. So y'all, that goes back to what we said up here. If you got different bases with single variables like this, there's only one number that you can put in for those x's to make these both equal the same thing. Okay? Y'all notice this, when you're solving equations, sometimes you got to break out factoring in some of these places, okay? So factoring is still in the game. All right, y'all, let's see. That puts us on number 7 here. Now, I'm about to show you a place where I would use the ln instead of a log, okay? Because I've been using the log every time. But watch this. I'm going to use the ln on this problem, and let's see why. Because I got an e to the t equals 525. You see this one like this? I don't know if some of y'all are maybe a little older in life like me, but it just makes you want to say phone home. If y'all remember that little movie about the ET. So I'm not even going to attempt to try to rewrite that 525 as the E being multiplied by itself. You cannot rewrite this one. But y'all watch this. Instead of the log, I'm going to take an ln of both sides. Because y'all watch this. ln of e to the t equals the ln of 525. So y'all, let me ask you this. What's going to happen on this left side if I have an ln of e to the t? Now remember, ln is a log base e, right? So that'd be like a log base e of e to the t. Pulling that your own game today, because all that does is that equals a t on that side, y'all. Okay, so that goes back to if the base matches the base raised to an exponent, that answer automatically is the exponent. Y'all, because the ln of e by itself is 1, and 1 times t is t. All right, y'all, so whoops, we're going to have to approximate this one, so I need my little squiggly equals. So now we need the ln of 525. Well, y'all, the ln button is right by the 4 on your calculator, I think. Punch that, punch in 525, and that one should round off to a 6.2634. Okay, so just remember on that one. Recall ln of e to the x equals x. In our case, t was our x, but y'all, same thing on it, okay? So y'all, how about this? E negative 0.50 t is going to equal 0.30. Well, guess what? I'm not going to try to rewrite that one, so I cannot rewrite. So y'all, we're going to take the ln of both sides because we got that e here again. So take the ln, so ln e to the negative 0.50t will equal the ln of the 0.30. All right, so I guess the question of the day, what is the left side going to be? Oh, y'all, that was on y'all. What's the next thing I'm writing on my left side? Now, am I actually going to write all of that in that? Because remember, this goes back into this case, L into E to the X equals X. So L into E to this big X, it still equals the negative 0.50 So Jackson, looks like you was writing that out, that negative there. And then bring down my ln of 0.30. So just like this one, other than now, I got a little more work on this one because I need to now divide both sides by that negative 0.50. So that's going to equal our ln of 0.30 divided by the negative 0.50. So that's going to cancel, giving me my t. And then we'll approximate this one again. Now, on that one, I'll do it on the calculator. But you definitely got to do your ln 0.30, close the parentheses, then divide by a negative 0.50. All right, I'm going to round it 4 spots. Oh, so that's what, a 2.407. So the 9 has a 4 after it, so we're going to keep that a 9. So 4079. Okay, y'all, so that's the trick on these problems when you got the E. Do the LN because it saves you a step of having to divide this side by that LN stuff, okay? All right, so we had one more exponential problem. 12 to the x equals 4 to the x plus 2. So y'all, I can't assume this one will be 0 because if I put a 0 for that x and a 0 for that x, I still have a 2 over here. So I can't do like I did the one while ago where I said, hey, they got different bases. Those exponents would both have to be 0 because this one's not a single variable over here. It's got a 2 added to it. So this one we actually got to work out, okay? But guess what? I cannot rewrite. So since we cannot rewrite it, we're going to take a log of both sides. The log of 12 to the x will equal the log of 4 to the x plus 2. All right, so we did that so we can bring our exponent stuff down to the front. So the left side, you're going to get an x times a log 12. Now, y'all watch this. There's 2 parts of this exponent. So when I bring it down, I'm putting it in parentheses, x plus 2. And then that'll both be times this log 4, okay? So you can't do x plus 2 log 4 without the parentheses because the log 4 has to get multiplied by both of these, okay? So that would be my next step is to actually multiply both of these by the log 4. So I get my x log 12 So this side, x times log 4 gives you an x log 4 plus 2 times the log 4 gives me a 2 log 4. Okay, so I do this extra step so that y'all realize that both of these have to be brought down and multiplied by that log 4, okay? So y'all, here's the thing on this one. I got an x over here and an x over here. But this x on this side has other stuff with it. So what I really want to do is move this x log 4 over to this side. And in order to do that, we're going to subtract it from both sides. So we're going to subtract x log 4 from both sides. So y'all, want y'all to see this. These are not like terms. So that'll be a x log 12 minus the x log 4. So that's now my left side. Now, y'all, on the right side, the x log 4 and the negative x log 4 cancels. So all that's left is the 2 log 4. So y'all, I'm back to the dilemma again. I've got an x here and I got an x here. These are not like terms. So I need to break that x somehow so that I got x's as one variable on that left side. So what can I do to both of these that would help me solve for that x? Okay, so I'm trying to figure out where y'all getting that log 3 at. Okay, but I think I'm seeing what you wanted to do. Since there's an x in both of these, remember the factoring stuff. I'm going to factor out that x. But that leaves me a log 12 minus log 4 in my parentheses. Yeah, there you go. Now, this log 12 minus log 4 is basically one big number. So if I want to get the x by itself, I need to divide both sides by log 12 minus log 4. So log 12 minus log 4. All right, and I'll do that on the right side. 2 log 4 divided by log 12 minus log 4. Y'all, look, this stuff cancels. That brings down my x. Now, y'all, here's the thing on this one. You got to close the parentheses around all of your logs. Now, if you hit the alpha y equals, you can put it in just like a fraction like this. If you put this one in and you do like 2 log 4 divided by, if you do it like that, you would have to put extra parentheses around that denominator. Okay. So let me show you the 2 ways you can actually punch that in. All right. So the first way was to hit the green alpha button and the y equals and hit enter on ND. Doing it like that, I can do my 2 log 4, close the parentheses, arrow down, and then I can do my log 12, close parentheses, minus my log 4, close parentheses. So that looks exactly like it looked So watch this, I'm gonna hit enter. So 2.5237, we'll keep that as 7. Now watch the other way I was talking about. You can do 2 log 4 divided by, at this point, since the bottom has more than more than one part, the whole bottom will go in its own set of parentheses. And then I'll do my log 12, close its parentheses, minus my log 4, close parentheses, and then I would close parentheses because that's the end of my denominator. So notice, you got to have the extra parentheses in the bottom of that fraction, and then you hit enter. You get the same answer, okay? Now, watch what happens if you don't use those parentheses. Say you did 2 log 4 divided by, what was my bottom? Log 12 minus log 4. So I didn't use the extra parentheses, y'all, so watch what happens. It gave me the wrong answer, okay? So you want to do the extra parentheses like this one, okay? Alrighty, y'all, so that was the exponential equations. So what we got coming up for our second type of equations, we're going to be solving logarithmic equations. So those will look like this: log base A of X equals Y. Okay. So we now have our log stuff going on. Oh, y'all, it looks like it's pretty much close to break time. So let me pause this. Um, so it's almost, so how about we take our break till 11 o'clock? And then when we come back at 11, we'll knock out our logarithmic equations, okay? All right, y'all, we'll see y'all in 10. All right, everybody, I am showing 11 o'clock. So it's time to get into solving our logarithmic equations. So let me get us recording. All right, y'all. So a little property that helps us in this section, similar to the base exponent property, we got what we call the log base property. So this property is similar. It says if log base A of X equals the log base A of Y. So two sides are equal. They both got the same base to the log. Then that means X equals Y. That means these results got to be equal if the log bases are equal, okay? So that's going to sort of help us in some spots if we can get to this kind of situation. Hey, also, here's the steps to solving logarithmic. Now, the first thing you got to do, no matter what, if needed, you got to combine logs on either side of the equals. So combine logs on either side if needed. So if I got a log of something plus a log of something equal to whatever, I got to combine those two logs into a single logarithm. And that's when you're either going to use that product rule of logarithms or you're going to use the quotient rule of logarithms, okay? So remember, if they're being added, we write them as a product. If they're being subtracted, we write them as a quotient, okay? Now, at that point, you got two cases that can happen. We have a log base equal to a log base. So this is sort of like if I got a base equal to a base on each side, do an exponential. If I got a log base equal to a log base, then set the results equal to each other. Now remember, the results is the X and the Y. So you're going to set them equal to each other. And then you're going to solve for the variable. And then remember, if needed, check if needed. So y'all, it's not too bad if you got a log base equal a log base. If no log base, so if log base is not equal, so if your two log bases are not equal, then we rewrite as exponential. And remember, that's when y'all took the log and you took the base A to the exponent Y equaled that result X. So that's what we're talking about. Rewrite it as exponential. Solve for the variable. And then check if needed. Now, here's the thing about this. Since these are logarithmic equations, remember one thing. What if I end up with a negative answer for my x? I can't take the log of a negative number, remember? When y'all was doing that homework the other day for 9.4, what happened when we took the log of a negative number? We ended up getting does not exist. Remember? It said it was non-real answers. So that's why when it says check if needed, remember, we cannot take logs of negative numbers. So if I get two answers and one of them's negative and it gets substituted back into my equation and gives me taking a log of a negative number, I can't take that answer because it's not real, okay? So y'all, I'll show you when that kind of case happens. All right, y'all, same thing as a while ago. Solve for x. These will start at number 10. Log base 2 of x equals 4. All right, so I don't need to combine logs on either side. I've only got one log on the left side and none on the right. Now, I don't have a log base equal to a log base because I don't even have a log on the right side. So I got to go to this case. If the log bases are not equal on each side, it says rewrite as exponential. So I'm going to rewrite this as exponential. So the base is 2. The exponent is 4. Because you got to remember the base and the result, evaluating this gives you that exponent. So the right side on the log is always the exponent. And all that's going to equal the result, which was my x. Okay. Now, we only got to do one thing to solve that, and that's figure out what 2 to the 4th power is. So y'all, if you multiply 2 times 2 times 2 times 2, we get 16 equal to our x. So let's put a 16 in. If you punch your calculator on the log base, if you did a log base 2 of 16, hit enter, it'll give you 4. Okay, y'all, so not too bad if we can rewrite those. So watch this, number 11. Log of x equals -4. All right, well, guess what? I don't have no logs to combine on either side. There's only a single log here. I don't have a log base on each side, so the log bases are not equal. So I'm going to rewrite as exponential. So I'll just put rewrite. Oh, I don't have a base though. So what might be my base, y'all? What would I put as my base here? Oh, what y'all got? 10. Good job, y'all. So that'd be 10. Exponent is -4. And that's going to equal my x. All right, so all we got to do is evaluate what 10 to the -4 is. So y'all, what you do on that, since that's a 10 to the -4, you would write a 1 and move the decimal left 4 times. So that would be once, twice, whoops, hold on, once, twice, 3, 1 more 0, and that'll be 4. So that you get like a 0.0001, okay? I think it wants that answer in decimal form instead of writing that 10 to the -4th. But remember, this is just 1 times 10 to the -4th. So you write your 1 and move it left 4. If that's a 5, you move it left 5 and so on, okay? All righty, so we're moving on to, what do we got next? Number 12. All right, y'all, a log base 4 of 5x minus 4 is going to equal 1. All right, no logs to combine on either side. I don't have a log equal to a log, so I don't have the log bases equal. So we're going to have to rewrite this one. So your base is a 4. Your exponent is the 1. And that equals your result, which is a 5x minus 4. So basically, we're going to solve this for the x. So first off, 4 to the first power is 4, equal to my 5x minus 4. And y'all solving that, we're going to add 4 to get the x by itself. So that moves that negative 4 over. So 4 plus 4 gives me 8 over here, equal to our 5x's. That stuff cancels. And what? We want a 1x here, so we need to divide by 5. All right, y'all, we can't do nothing with the 8/5. But over here, 5 divided by 5 makes that 1x. All right, so that's not negative. But if you put the 8/5 in, the 5's cancel. 8 minus 4 is 4. So 4 to the first power equals 4 would check out. All right, so notice on those first few, my first step was to rewrite them all as exponential. But y'all, let's change it up a little bit. Let's do this. Log x plus log x minus 3 equals 1. So y'all, the very first step said, if needed, combine logs on either side of the equals. Well, over here, I got 2 logs, so I need to combine the logs here. We need to write these as a single logarithm. So you got a log on both of them, so bring out the log. So my question to you all would be this. If these logs are being added, will I rewrite this as a product, or will I rewrite this as a quotient? And y'all, what you got to think about is which one of them logarithmic properties that I use for adding. All right, that looks like we're writing it as a product. Good job. So this would be the log of our x times x minus 3. All that is going to equal 1. Now I'm going to go one further step. Since this is the product, we're going to multiply that stuff. So let's bring down our log. So the x times x is an x squared minus x times 3, which is 3x. All of that equal to 1. So good job, y'all. It's definitely a product. And then actually multiply it to get it to this point. Now I'm at the point where I got a log on one side equal to a number. So the log bases don't match. So since the log bases don't match, at this point, we're going to rewrite it as exponential. So the question is, what was my base? Well, y'all told me a while ago that would be a 10 if there's no base. So I got 10 to the exponent 1 equals x squared minus 3x. So the base, exponent, result. All right, y'all. So my next step, 10 to the first is basically 10. That's going to equal x squared minus 3x. So y'all look here, this one's quadratic because we got an x squared term. So since it's quadratic, we need to set everything over here equal to 0. So to make the left side be 0, we're going to subtract 10. So y'all look at that. 10 minus 10 is 0 on that side. That's going to equal my x squared minus 3x minus 10. So y'all look at that. We got a quadratic equation. Now, we're going to solve it by factoring, but if you don't like factoring, you can do the quadratic formula. Or if you don't like the quadratic formula, you can graph it on the calculator and look for the x-intercepts, okay? Because all these will be factorable in this homework section. So you can graph them to find the zeros, factor it, or use the quadratic formula. So y'all, we're going to factor it. X and X. All right, y'all. So factoring's on y'all. So let's see. What do y'all got? That got me a -5 and a +2. So y'all remember, last number is negative. These will have unlike signs. Good job. And then you look for factors of 10 that subtract to get 3, which were 5 and 2. And the bigger number always has to be the same sign as the middle, okay? All right, y'all, so I would set both these equal to 0. And solve those for the x's. So here, we're going to add 5, it looks like. Here, we're going to subtract 2. But y'all guess what? What's my final answer? X equals 5. Good job. Y'all cannot take that -2 because if you plug that -2 in for that x, log of -2 does not exist. So we cannot keep the negative number. So cannot keep the negative answer. Okay. All right, y'all. So logarithmic equations can be sort of long and tedious at times, but you just got to remember we're following those rules from yesterday to turn the sums of two logs into products, okay? All right, now watch this one, y'all. 14. We got logs everywhere on this one. I got a log base 4 of x plus 21 minus a log base 4 of x plus 5 equal to a log base 4 of an x. So y'all looking at it, I got logs on both sides, but look at this. The left side has more than one log. So these two on the left side, we're going to combine logs over here. So they both got log base 4. Actually, all of them got a log base 4, right? So all the log bases are matching. So pull out that log 4. So we got subtraction. Subtraction means we're going to have a quotient over here. It's going to look like a fraction. The positive factor goes to the top. So that's the x plus 21. The factor being subtracted goes to the bottom. So that's the x plus 5. That's going to equal my right side, which is a log base 4 of x. Oh, are y'all noticing that? This log base on the left side equals the log base on the right side. So my log bases match. So since these log bases match, this result equals that result. So the x plus 21 over x plus 5 equals the x on the right side. Now, y'all, we sort of solved some of these problems earlier, but the trick over here, when you're solving fractional type equations, make the right side look like a fraction, and then I'm just going to cross multiply. So remember, cross multiplying, I take the x plus 21, multiply by the bottom on the other side. So x times 1 is x, plus 21 times 1 is 21. Then I take the bottom of the first fraction, in both of those, multiply by the top on the other side. So that's where you're getting that cross at. So x times x is x squared, plus 5 times x, 5x. So notice, it's quadratic again. So we need a 0 over here. So we need to move the x. We're going to subtract the x from both sides. We're going to move the 21 by subtracting 21 from both sides. Because look, x's cancel, 21's cancel. Y'all, the left side is now 0. So over here, the x squared comes down. The 5x will add to that negative x, giving us 4x. And then the negative 21 has nothing to add to, so we bring it down. So y'all look at this. Another quadratic equation. So we're going to factor this. Or like I said, you can graph it, look for the x-intercepts, or quadratic formula. All right, y'all, so that's negative. So 1 of each, 1 plus, 1 minus. All right, what do we need? We need what, a 7? There you go, positive 7 and a negative 3. Okay, and you check your signs by doing 7 minus 3 is 4 positive, right? All right, y'all, set them equal to 0. So it looks like we're getting a negative 7 and a positive 3. And guess what? There's that negative answer again. If I put that negative 7 in here, this thing is not a real number. So get rid of that negative answer, and we only keep the positive 3. So once again, cannot keep the negative answer. But y'all look at it, this problem had a lot of stuff. We had to combine logs here. We had the log bases match here. We had to solve that by cross multiplying. Here, we had to factor. And then at the end, we had to figure out, hey, we can't keep a negative answer, okay? So, whew, that had a lot of steps to it, okay? So y'all, let's see what we do here. Log base 4 of x plus 1 minus log base 4 of x all equals 4. So y'all, I'm going to play with y'all on this one. So really, what's the first thing I need to do to this problem? And y'all can just tell me the steps instead of sort of writing out your answer if that'll make it easier. All right, so we're going to combine them. So good job. You got 2 logs on the left side. We're going to combine logs. So we're going to bring out the log 4. So how about this, Nat? If I'm going to combine the logs, will they be a product or will they be a quotient? So they're going to be a quotient. Good job, y'all. So the x plus 1 over x. And y'all, that's going to equal the other side of a 4. Oh, but y'all look here. I don't have log bases on both sides. Okay, I can't get this situation. So since I don't have log bases on both sides, what's my next step then? Oh, good. Oh, good. You rewrote it. Good job. Good job. So we're going to rewrite, remember, when we don't have a log on both sides, we got to rewrite it as exponential. So my base is 4. My exponent is 4. And that's going to equal to x plus 1 over x. Good job. So 4 to the 4th power. Well, if you do 4 times 4 times 4 times 4, y'all, that's going to equal 256. That's going to equal our x plus 1 over x. So now this pretty much looks like this. All I'm going to do is put me a 1 under it, and I'm going to cross multiply. 256 times x is 256x. That's going to equal to 1 times x plus 1, which is x plus 1. All right, so we're solving for x here, but I got x's on both sides. So since I got a whole lot of x's on this side, I'm going to move this x to the left side by subtracting. So I got 256x's minus 1x leaves me 255x. Y'all hear my x's cancel, and I'm left with 1. Oh, y'all, look at that. My final step. Turn that 255x's into 1x. So we need to divide both sides by 255. So that cancels, giving me 1x. Oh, y'all, we can't do nothing with that. So that's going to stay 1 over 255. All right, so y'all, that is the trick. Do I need to combine logs? Do my log bases match like here, or are they different? If they're different, I got to rewrite. If they're matching, then that's the results equal to each other. Okay? All right, y'all, so if any of y'all are doing your engineering and stuff like that, you'll get to play with these logs in calculus and all that fun stuff. All right, y'all. Let's see what they did here. Log base 2 of an x plus log base 2 of an x minus 1. That's going to equal a log base 2 of a 6. All right, first step. All right, y'all, so we definitely got to combine this left side. So I got a log 2. And they're being added. So we know this will be a product. So we'll have our x times x minus 1. That's going to equal a log 2 of our 6. And y'all, I'm just going to multiply this out real quick so that I get my log 2. And my product, x times x is x squared. X times negative 1 is a negative x. And then that'll still equal my right side. So, y'all look at that. We got log bases that match. So since they match, what do we got? X squared minus x, good job. X squared minus x, and that's going to equal the right side, good job, which is a 6. So result equals result. Uh-oh, y'all. Quadratic again, so move the 6 over here by subtracting 6 from both sides. X squared minus x minus 6 equals 0. All right, so y'all know what time it is. It's either time to graph it or factor it to get all your answers, right? So I guess since we're factoring, y'all factor that out. Get me factors of 6. So you got unlike signs. So what do you got? -3, +2. Okay, y'all. So if you notice, all these log equations have been negative at the end so that you're going to get a negative and a positive because you're only going to keep one answer in the long run, okay? So that means one's getting thrown away and it's always going to be whichever one comes out negative. All right, y'all, so here we go. Adding 3 and then subtract 2. But y'all, if you'll notice, once we got something factored, the answers are just opposite than what these numbers are every time, okay? All right, so my final answer would be, well, I can't put a -2 up here because the log base 2 of -2 is not exist. So I cannot keep a negative number again. So my only answer, positive 3. All right, y'all. So they got one more for us. So let's see what we got here. A log base 2 of x plus 2 plus log base 2 x minus 2. All of that equals a 5. All right, so y'all do know they're being added, and there's 2 of these logs over here. So we will combine, okay? So we'll bring out our log 2. So y'all are being added. So this will be a x plus 2 times a x minus 2. All of that equal to 5. And y'all, I'm actually going to go a step further and multiply this. Now you look here, these are conjugate pairs. So watch this. Bring down that log base 2. So y'all, why don't y'all FOIL that for me? See what I get when I multiply x plus 2 times x minus 2. Oh, y'all done got that for me. What y'all got? It? X squared minus 4. Good job. Y'all, conjugate pairs, x times x is x squared. 2 times negative 2 is negative 4. Remember, conjugate pairs, we don't have to FOIL the long way, okay? All right, each of this equals 5. So, next step. What are y'all doing to this next? So that looks like we rewrote it as exponential. Good job. We're going to rewrite. So y'all, once again, I didn't have the logs on both sides, so my only choice is to rewrite it. So we got 2 to the 5th. That's going to equal that, x squared minus 4. All right, so what is 2 to the 5th equal? So let's see, that was all right, so that let me catch up. So 2 to the 5th was 32. That equaled x squared minus 4. Now what Natalie did was she took this plus 4 to both sides. And I got 36 equal to my x squared. Now the reason we're putting the numbers on this side, y'all, now if you brought the 32 over here, you would have x squared minus 36. You could factor that doing the perfect square stuff to get your 2 answers. Or since there's no x term in the middle like these all had, we can do the square roots. So square root of 36 equals square root of x squared. So remember, that'll give me what? A positive and minus 6 equal to my x. But y'all remember, I cannot take the negative answer. So the only answer I can take is the positive 6. Now, y'all, like I said, at this point, you could have said x squared minus 36. You could have done it like that and factored it into x plus 6, x minus 6, and then solved both of them. And you still would have got rid of that negative answer, okay? So I just wanted to remind y'all, when you got an x squared in numbers, put the numbers on one side and do that square root, okay? All right, so once again, cannot keep, negative answer. All righty, y'all. So that is 9.7. We solved exponential equations. We had two cases. We either had the same bases on both sides and we set them equal to exponents, or we had to take logs of both sides. On our logarithmic equations, you always started them out by combining logs if you have to. And then we looked at, did we have the same bases on each side for the log? If we had logs on each side, we set the results equal to each other and solved it. If we didn't have logs on both sides, we rewrote it as exponential and then solved it that way, okay? So I will say this, y'all, on Monday, we're going to look at another formula for interest, like we did with the compounding and all that. But we had compounding that was like monthly, quarterly, and all that. The formula we used Monday, we used to find exponential growth or exponential decay. Those have what we call continuous compounding. And I'll show y'all that formula on Monday, okay? So we're looking at exponential growth like COVID did when it came around and them charts shot up and stuff like that, okay? All right, y'all, so I'm going to stop this share.